Alright guys, welcome to class. I'm sorry I can't make it there today. I'm on my way to a coach's clinic down in Kansas City. So this little moto of me will be kind of popping up from time to time. Hopefully you enjoy it, and if not, too bad. So go ahead and get your notes out, get ready to take some good notes, and let's get going.
All right, so we're going to talk about the Cambrian time period. Pretty important time period in Earth's history. A lot of what we know of our planet species today is due to this time period. So, kind of the couple big things that we need to know is that what is a trigger for this? We talked last time about how multicellular was being kind of a big thing, but more importantly, there has to be some other stuff. So the first thing we see is that around 600 million years to 500 million years ago, we get this rapid time of evolutionary change. An experiment. There are these crazy species that appeared in the fossil record for the first time. And a lot of these things, none of them were around since then. They came into existence and then they're gone. I'll show you a couple pictures of some of this stuff. These life forms almost seemed alien. Stuff nothing like it today. Very kind of crazy creatures that, once again, not a lot of things like it around. So all these species all kind of came about during the Cambrian explosion. Not only did that happen, but we also had life kind of more what we're used to seeing. All the different lineages, you can kind of look down this chart, all have this time period in the Cambrian time period, from insects to slugs to chordates. That's going to be things with backbones like you and us. All have our origins back here. So it's a very important time in Earth's early history. Some of the best evidence of the Cambrian time period can be found in the Burgess Shale. That's in the Rocky Mountains in Canada. You can literally walk down the side of this mountain and just see tons of all these fossils of things like this, things like that can be seen in this picture, all in this Burgess Shale. One of the most famous fossils that can be found is the trilobites. Trilobites can be found. I'll show you a picture of that on the next slide. So once again, there was more types of extinct fossils living during this time period than any animal phyla living today. Okay, we have to have some cause of that. All of this is also all in the ocean. You got to remember, none of this is on land, and with that, the period that's going to follow it is the Ordovician period, and once again, still only in the ocean. Just some more images of some things that would have been found around that time of species. Where we're specifically talking about is here. If you kind of follow the timeline, back in the back in this period when life started, you can kind of see how that goes. And as we move back down, you're seeing, not a lot of life, not a lot of life. Then all of a sudden, right around here, you're getting this huge diversity of life and all the kind of what we typically think of as on our planet. So there are a couple different theories on how or what caused the Cambrian explosion to kind of occur. Usually we use a general time period for this. For our test, we'll say approximately 541 million years ago, so that's a good date to know. But there will be a couple causes. The first one that I think we should give credit to is the changing of the environment caused by the breakup of Gondwanaland. So as Gondwanaland breaks up, it creates, again, by the way, let me back up. Gondwanaland is the first supercontinent. As it breaks up, it creates these shallow seas. Shallow seas, you think about on our planet, great places for life to abound. So when the first time on our planet, we have tons of shallow seas available for life to kind of become diverse. Our second cause that would be an idea that could help would be that there has to be some development of kind of what's going on with the organism itself. And so the second thing that we attribute is the development of bilateral symmetry. Now, bilateral symmetry, simply put, before this we have what we call radial symmetry. So if you think about a jellyfish, for the most part, you can cut it and it's all going to have equal sides. Bilateral symmetry, for the first time, is when we have a structure, okay, like a nematode, that you can only cut it one way. This half, they're not going to be equal, so we only have one type of symmetry. Obviously, humans are a good example of bilateral symmetry. So we can see here, the radial symmetry up above versus a sponge that has no symmetry to a beetle that has bilateral. A turtle also is a good example of bilateral symmetry. Now, why is this important? It's because of a term called cephalization is the development of the brain. And when we think about what that's going to entail is we're going to see that the brain itself is going to be a product of bilateral symmetry, and so those go hand in hand. So we got breakdown of Gondwana land, development of bilateral symmetry, increased cephalization, so those are three things. And the final thing, it was a new sense developed. The new sense was vision. So the eye is going to develop during this time, huge advantage. So if I was writing an essay, I would say that these four things, along with something we already talked about, being multicellular, was a key ingredient in the development of the huge diversity of life that we see during this time period. Another thing that's going to have a huge impact on evolution is mass extinctions. We're going to actually spend time next time in class talking more about these. So hopefully, you'll learn a little bit here. At the end of, we had Cambrian period, then the Ordovician period, we're going to have a huge loss of life. And it happens right around 444 million years ago. Those smart guys in class can probably figure out that that's going to be something that we need to know is that date, 440 million years ago. And it was one of the first of the major mass extinctions. There's other mass extinctions that occurred, and like I said, we'll talk more about these, but this is the first of those. Another mass extinction that you're going to need to know the date of, 360 million years ago. Another one about 260. The big one is this Permian time period. It was really devastating. Killed off a lot of different life on our planet. And we'll spend some time talking about that. It's also known as the Big Kill. 35 million years later, another mass extinction. All of these things have a bunch of different causes. What's going to be important for us to do, and this is going to be done mainly next time in class, is to look at each one of these, remember the dates, and then also figure out what caused each of these mass extinctions. By the way, this video is going to be up on the portal, so if you missed something, or if you're obviously not in class, you can watch it then. When we look at the different time periods, almost all of these time periods can be characterized by the ending of a mass extinction. So, for example, the Cretaceous period right here, that's when the dinosaurs were around, or during these green area here, it's marked the end of it at 65 million years ago by the extinction of the dinosaurs. The Permian extinction right there was 251 million years ago, ends the Permian time period. So we usually a lot of times rate different time periods by the mass extinctions that kind of end one organism's reign on our planet, and another one kind of takes it. This is kind of a cool image. I like that. Number one, if you start back way down here, you notice how the Earth is, red. It's lava. It hasn't. Then it starts to harden. All of a sudden, we start to get some oceans that form. Still no life on our planet. If you travel back in time, wouldn't get very much to see. The water levels are going to change as we go through. We're going to keep going up, and then all of a sudden, once we start getting into that Cambrian time period, we're going to see this huge diversity of life. Another milestone that we're going to talk about next time is this one right there. Right? Look at that. Nothing on land. All of a sudden there is. What caused that? Who was the first ones to get on land? An important time period. And then kind of wrapping all the way up to modern day with us. Another mass extinction event that shaped our Earth was the one 65 million years ago. Killed the dinosaurs. It's one of the more famous of the mass extinctions, and once again, we'll spend some time on that. The last thing on this slide I want to talk about is a lot of scientists, not a lot, most scientists know that we're under the sixth mass extinction event. This mass extinction event has been occurring since the invention of agriculture. It's caused the death and destruction of a lot of different species on our planet. Things that are obviously taxing that now, things like global warming, carrying capacity, how much food and resources we are using on our planet. All those things are having an impact on our Earth, and more importantly, on organisms. And we'll look specifically at this last mass extinction as well. So Next class period is going to be really kind of focused heavy on mass extinctions. That last line, if you can't read it, says by 2012 there will be about 8 billion people on our planet. I'll go ahead and let you fill in those notes real quick. And one more slide I just want to put on there. It's just kind of a reminder for us. I'll show it to you here in a second. So you should remember this: kingdom, phylum, class, order, family, genus, species. We talked a lot of different ways to remember that. My favorite one is kids playing cars on freeway get squashed. It's just important because we'll be talking about different groups, and I'll be talking about, oh, this family went extinct, or this group. We're not talking about individuals' family, obviously, but we're looking at it this way. So if I said, hey, monkeys went extinct at this time, that's kind of what I'm referring to. So make sure you know this for the test in that order: kingdom, phylum, class, order.